So far, our discussion on particle motion was concerned about motion of particles in one dimension. In other words, we considered a particle moving either in the x direction or in the y direction. Now, do you remember the equations of motion for a particle that is moving in the x direction? Let's write the equations of motion for a particle that is moving in the x direction. Now, the first equation will be Vx equal to Vx0 plus At. What does that equation mean? V sub x is the x velocity at any given time, is Vx0 stands for the initial x velocity plus a times t. The displacement x equal to x0 plus Vx0t plus 1/2 at squared. That is the displacement equation. And Vx squared, the final x velocity squared, is Vx0 squared plus 2ax. Well, these are the equations adapted for x motion. Now, what will happen to these equations when you want to discuss y motion? Well, when you want to discuss y motion, it will become Vy. The y velocity at any given time is Vy0 plus, well, you see, when you consider y motion, the acceleration a will become negative g. So, in place of plus at, it will become minus gt. I hope you understand that. For a vertical motion, the acceleration is negative g. So the a gets replaced by negative g. And the displacement equation y equal to y0 plus Vy0t. What does Vy0 stands for? Initial y velocity minus 1/2 gt squared plus 1/2 at squared become minus 1/2 gt squared. And finally, Vy squared equal to Vy0 squared minus 2gy. So these are the equations. This is specifically for x motion and this is specifically for y motion. Well, in this lesson, we are going to look at motion in 2 dimensions. That means an object will be moving in the x direction as well as in the y direction simultaneously. Now, look at the gun I have here. I can actually project a ball from this gun. I can load the gun. And I'm going to project it horizontally. When the ball comes out, the moment it comes out, it will have an x motion and a y motion. See if you can, try if you can see the motion of the ball. There you are. Now, did you see how the ball was moving? Well, I want to take you to an animation and show you how the ball was moving. Give me a second. To illustrate motion in 2 dimensions, I have arranged 3 balls here. The ball sitting on this platform can only move in the x direction. This ball can only move in the y direction. whereas this ball is going to be projected horizontally. Alright, I want you to watch the motion when I run this animation. Alright, watch carefully. I'm going to run it. And watch each frame. There you are. Now, what do you observe? If you look at this, well, this thing did not move. Alright, I'm going to run it again, and I want you to watch it carefully. What I have done is, the horizontal velocity I have given this ball is the same as the horizontal velocity for the ball that can only move in the x direction. So this will move in the x direction with a velocity of 8 meters per second. This is given a horizontal velocity of 8 meters per second, but it is not supported. It is like the ball that was fired from the gun. Alright, watch this animation one more time and watch it carefully. Now, what you notice is this. After 1 second, the ball that is projected, the initial position of the ball was here, if you notice. And unfortunately, those initial positions are not shown in this animation. The ball that is fired or projected is now here. It has now a vertical motion and a horizontal motion. And look at the ball that is moving horizontally only. It has moved the same horizontal distance. And look at the ball that is being dropped. It has dropped the same vertical distance. You see that? After 1 second, the horizontal position of the projected ball and the horizontal motion of the ball that is moving on the platform are exactly the same. Similarly, the vertical motion of the projected ball is exactly the same as the vertical motion of the freely dropped ball. Look at the velocity, the vertical velocity of the dropped ball is exactly the same as the vertical velocity of the projected ball. Now, look at the position after 2 seconds. The vertical position and the horizontal positions are exactly the same. That means the horizontal and vertical motions of this projected ball are independent of each other. What does that mean? It means this horizontal motion will not affect the vertical motion, and the vertical motion will not affect the horizontal motion. We can treat each motion as though the other did not exist. That means we can use the equations of motion to describe the x motion of this ball and y motion of the same ball. Now tell me, the velocity of this ball, x velocity is vx. You look at this. What happened to vx with time? As the ball keeps falling, what is happening to the x velocity? The x velocity is not changing. Why is it not changing? Because there is nothing pulling or pushing in the x direction. In order for the velocity to change, there must be some force. Since there is no force in the x direction, the x velocity will remain the same. And that's the reason why the motion of the ball on the platform that has the same x velocity is exactly the same as the motion of the projected ball. Okay, let's go and look at the motion in 2 dimensions constitute a projectile motion. So a projectile launched into space constitute motion in 2 dimensions. A projectile moves in the x direction and y direction simultaneously. A projectile may be launched horizontally, just like I just showed you, or at an angle theta with the horizontal. Now this is an example of a horizontal projectile. What you notice here, you are projecting a ball from a certain height with a velocity, with a horizontal velocity v sub x. Now what is the initial vertical velocity of the projectile? The initial vertical velocity of the projectile is 0. Vertically, it is not moving in the beginning. It has an initial horizontal velocity and it has an initial vertical velocity that is 0. And you can see, as the projectile keeps moving, the vertical velocity keeps on increasing. What is the equation for that vertical velocity? Vy equal to Vy0 minus gt. You can see the velocity keep on increasing in the negative y direction. What happens to the horizontal velocity? The v sub x will not change because there is nothing pulling or pushing in the horizontal direction. Well, projectiles at an angle we will discuss in our next part of this lesson. Okay. Now a horizontal projectile, that is what we're going to concentrate on this part of the lesson, has a horizontal motion and a vertical motion. And I showed you some time ago that the horizontal and vertical motions are independent of each other. What does that mean again? The horizontal motion does not know that there is a vertical motion. In other words, the horizontal motion will not affect the vertical motion, and the vertical motion will not affect the horizontal motion. Now, take the same example. The horizontal motion continues as though there is no vertical motion. In other words, the horizontal motion of this projectile here is exactly the same as the horizontal motion of the ball on the platform. You see? The horizontal motion continues as though there is no vertical motion. And the vertical motion continues as though there is no horizontal motion. The y velocity will keep on increasing according to the equation Vy equal to Vy0 minus gt. The horizontal velocity v sub x remains a constant. And the initial vertical velocity Vy0 is 0. There is no vertical velocity in the beginning. And as time goes on, the vertical velocity increases in the negative direction. The vertical velocity Vy increases downward like that of a freely falling object. You remember my first animation. The motion, the vertical motion of the freely falling ball and the vertical motion of the projected ball are exactly identical. The acceleration for the vertical motion is negative g, which we talked about. That means the equation for the velocity of the vertical motion is Vy equal to Vy0 minus gt. Now Vy0 is 0. The initial vertical velocity is 0. That means Vy equal to negative gt. What is the value of g? G is 9.8. Therefore, at the end of the first second, the vertical velocity of this ball will be negative 9.8 meters per second. At the end of 2 seconds, its vertical velocity will be negative 18.6 meters per second, and so on. The y velocity is negative gt. And therefore, the velocity vector, now look at this, at any given position, it has an x velocity and a y velocity. So look at the vector equation for the velocity of this projectile at any given instant. It has an x velocity vx, which remains a constant, and a y velocity minus gt. So velocity of the projected object at any given time is v equal to vxi minus gtj. Vx is the x velocity that remains a constant, and minus gt is the y velocity. Alright, I want you to be very thorough with this equation. Alright, let me give you a scenario and let me see whether you understood our discussions. Two balls are held at the same height from the ground. This is the brown ball, and another one is the yellow or orange, whatever you want to call it. Now, ball 1 is dropped. This ball is dropped, and ball 2 is projected horizontally with a velocity vx. Alright? If you understood the concept, what is the concept? The vertical and horizontal motions of the projected ball will be independent of each other. Alright? The question is, which will fall on the ground first? This is dropped freely, and this is projected horizontally with a velocity vx. Which will drop on the ground first? Have you got an answer for that? Well, if you understood the concept I developed so far, you should understand that the vertical motion of this projected ball will be exactly the same as the vertical motion of the freely falling ball. That means both should fall at the same time. Is that right? Look at this. The vertical motion of the dropped ball and the vertical motion of the projected ball are exactly the same. After 1 second, you can see the red ball and the yellow ball. After another second, look at the vertical positions of the red ball and the yellow ball. The vertical fall of the red ball and the yellow ball are exactly the same. That means they will fall to the ground at the same time. Alright? So the velocity, the vertical velocity of the dropped ball and the vertical velocity of the projected ball, both will be given by Vy equal to negative gt. Alright? And here is an animation of that. You can see the red ball and the blue ball will fall at the same time. Watch the vertical motion there. They fall at the same time. Alright? Vx remains a constant, and therefore, what is the horizontal displacement? Horizontal displacement is, what is the horizontal distance at which the ball is going to fall? You see, this distance is traveled by a velocity Vx. Therefore, the horizontal displacement x of the ball is that uniform velocity Vx multiplied by time. There is no acceleration. So 1/2 at squared is 0. The horizontal displacement of the ball is Vx multiplied by t. And how about the vertical motion? The initial vertical velocity is 0. We talked about this. And so, what is the equation for the vertical displacement? Can you write the equation for the vertical displacement? You can see it is projected from a height y0. And so, y of t, the position at any given time t, is y0 plus vy0t minus 1/2 gt squared. This is the y position at any given time. What is the value of vy0, initial y velocity? It is 0. Therefore, you can say y of t, the y position at any given time is y0 minus 1/2 gt squared. Okay? Let's have a look and see if you can make this a little more convincing. Here I have an experimental arrangement whereby the flip of a switch can drop this ball and fire this ball horizontally that way. So you're going to have a blue ball dropped vertically and the red ball projected to the left with a horizontal velocity. Now watch the motions of these two balls. I'm going to flip the switch and watch the motions of these two balls. Now what do you see here? Well, you see the motions, do you see them moving and falling at the same? Let's look at it one more time. I'm going to drop the blue ball and project the red ball horizontally at the same time and see how they fall to the ground. You can see they both fall at the same time. Watch it one more time. So what you notice is that the vertical motion of the freely falling ball and the vertical motion of the projected ball are exactly the same, and that is the meaning that the vertical and horizontal motions of a projected ball are independent of each other. We will now obtain an equation for the time of fall of a horizontal projectile. How much time did the projectile take to fall to the ground? Now we will start with its y position function. How does the y position change? Y of t equal to y0 minus 1/2 gt squared, because the initial y velocity is 0. Alright? Now when the ball falls to the ground, what is the y value? When the ball falls to the ground, the y value will be 0. So the time taken by the ball to fall to the ground, the time taken to fall to the ground is the time taken for this y to become 0. Is that right? If I project this ball, now this is the one I just projected first. If I project this ball from an initial height called y0, now it goes and falls to the ground. When it falls to the ground, that y value will be 0. Okay, so we are looking for this time t when this y equal to 0. So we will say 0 equal to y0 minus 1/2 gt squared. And can you solve for y from there? Or we say y0 equal to 1/2 gt squared. Therefore, t squared will be 2y0 divided by g, or t equal to square root of 2y0 divided by g. Now, that means if you project a ball from a height h, in other words, your y0 is h, then the time taken by the ball to fall to the ground will be, in place of y0, I am using now h. The time taken by the ball to fall to the ground will be square root of 2h over g. Well, that is a very useful equation to remember. Now, let me ask you then, if I project a ball horizontally like this, the time taken for it to fall to the ground is square root 2h over g, where h is the height from where it is projected. All right, tell me in that case, if I drop a ball, just drop a ball from a height h, what will be the time taken by that ball to fall to the ground? Did you hear that sound when it falls to the ground? Yes. What is the time taken for it to fall to the ground? It is the same time. Why? Because the vertical motion of a freely dropped ball and the vertical motion of a horizontally projected ball are exactly the same. So in fact, t equal to 2h square root 2h over g can be used for any vertical motion. The time taken for the ball to fall through a height h, whether it is dropped freely or projected horizontally. Okay, now here I have another example of a ball projected, and you can see what I want you to watch in this animation is how the velocity changes. The horizontal velocity remains a constant, and look at the way the vertical velocity grows. According to the equation, Vy equal to Vy0 minus gt. Alright, and you can see as the animation proceeds, Vx does not change, but Vy keep on changing. Now remember that Vy is negative because it is directed downwards. Alright, this is y0. The projectile is projected from a height y0. What is the time taken for the projectile to fall to the ground? Well, the time taken is square root of 2y0 over g. And what is the horizontal distance traveled by that projectile? Well, horizontal distance is Vx multiplied by that time. So if I now write this time as square root 2y0 over g, I can now say x, the horizontal distance traveled, will be Vx times square root 2y0 over g. This is the time taken by the ball to fall to the ground, and during that time it has been traveling horizontally with a velocity Vx. So the distance x traveled, horizontal distance traveled by that projected ball is that horizontal velocity multiplied by the time of fall. Okay, let's move on. So y equal to y0 minus 1/2 gt squared, that gives us the time of fall square root 2y0 over g. Let's do a problem. A ball rolls off a table with a horizontal velocity of 2 meters per second. Means that is the horizontal v sub x, and falls 1.3 meter away from the foot of the table. What is the height of the table? So the question we have here is that you have a table. If that is the table, a ball rolls off that table. If I roll this ball and look at that, it rolls off the table, and the ball goes and falls at a distance x equal to 1.3 meter away from the foot of the table. Well, you can see, because we know the horizontal velocity and the horizontal distance, you see, we can calculate the time taken for the fall. Is that right? All right, let's draw that. Now this is the ground, and here is the table, and the ball is projected with a horizontal velocity Vx equal to 2 meters per second. And how is the ball going to go? It falls in a path like this. There you are. And the horizontal distance traveled is x equal to 1.3 meter. Now we are looking for y0, the height from where the ball was dropped, the height of the table? Well, you can see the ball projected there, is that right? Look at that one more time. There you are. Now, we find the time of fall t using what equation? Give me an equation for x. X equal to Vx multiplied by time, isn't it? X equal to Vx multiplied by time. Therefore, 1.3 equal to 2t, or t equal to 0.65 seconds. You see, we use the horizontal distance traveled by the projected ball to calculate the time taken by it to fall to the ground. And during this time, it traveled a vertical distance y0. So what is the equation for y0? y0 equal to 1/2 gt squared. Well, to be strictly, this is our equation. Our equation is y of t equal to y0 plus vy0 minus 1/2 gt squared. This is our y position equation. And we now know that during this time, this y will become 0. And Vy0 is 0. You understand that? During this time, 0.65 seconds, you see the ball falls to the ground in that time, then y will be 0. And of course the initial y velocity is 0. So I could write 0 equal to y0 minus 1/2 gt squared. And rearranging this gives you y0 equal to 1/2 gt squared. We know the value of g, we know the value of t. Therefore, y0 is 2.07 meter. The height of the table is 2.07 meter. You can see this can be applied in any situation of similar type. Okay, let's do another problem. An airplane traveling at 80 meters per second at an angle of elevation of 250 meters drops a box of supplies to skiers stranded in a snowstorm. At what horizontal distance from the skiers should the supplies be dropped? Now, I hope you understand this concept. Now, suppose this is the airplane traveling. And from the traveling plane, you're going to drop a box. Now, that means this box has the same horizontal velocity of the plane. So when the plane drops this ball, will it simply move vertically down? No. This box, well, assuming this is a box, I can't find the box, so I'm using that as my box. Well, suppose this is the box that the airplane drops. Now, just before it is dropped, you can see the box is moving with the velocity of the plane. So this has a horizontal velocity. What is the horizontal velocity of the box? Is the velocity of the plane. So the box is dropped with a horizontal velocity of 80 meters per second. It is a horizontal projectile. All right. Now what we need to find is the pilot has to figure out, you see, because the box will travel a certain horizontal distance. If those poor people are stranded, say somewhere there, the pilot needs to release the box much before he reaches directly above those stranded people. Then only the box will travel and fall where those people are stranded. So he's got to figure out how much will be the horizontal distance this box will travel. So our aim is to find the horizontal distance traveled by that box. Okay? All right. Vx initial, the velocity, the horizontal velocity of projection is 80 meter per second. And y0 is the height from where it is projected is 250 meter. Now here is the box that is dropped. Its horizontal velocity is 80 meter per second. And it is dropped from a height of 250 meter. We are looking for x, this distance. That is there the box coming and falling on the floor. Now look at the motion of that box again. It has an initial horizontal velocity. So this is how the box is going to fall. Now we need to find this x, and you know x equal to Vx multiplied by the time of fall. We know Vx, therefore we need to find the time. Well, it is very simple. Since we know y0, we can find the time of fall. What is the equation for the time of fall? T equal to square root of 2y0 over g. Is that right? Yes. So we use the values of y0 and g, and the time of fall is 7 seconds. And during this 7 seconds, it is traveling horizontally with a velocity 80 meter per second. So what is going to be the horizontal distance the box will move? The horizontal displacement of the box will be x equal to Vx multiplied by that time. That will be 80 meter per second times 7 seconds. That is 560 meter. Okay, let's look at another problem. Well, there is another part for it. Find the velocity of the box as it reaches the ground. Well, you see, when the box reaches the ground, suppose my hand, this hand is the ground. The box comes and hits the ground. Look at that. When the box hits the ground, it has a horizontal velocity. What is the horizontal velocity? 80 meter per second. And in falling through a height, it has also acquired a vertical velocity. That means it has a horizontal velocity and a vertical velocity. All right, let's find these velocities. Its horizontal velocity is Vx equal to 80 meter per second. And we will find the vertical velocity using this equation. Vy equal to Vy0 minus gt. Now, what is Vy0? What is the initial vertical velocity of the dropped box? It is 0. Therefore, Vy equal to negative gt, negative 9.8 times 7. We calculated the time taken by the box to fall. So that is negative 68.6 meter per second. So that means the box, when it falls to the ground, the instant when it falls to the ground. I know most of you would say, but don't the box come to a rest? Yes, it will. You see, the instant when it touches the ground, it has a horizontal velocity and a vertical velocity, which is this. All right, so the vertical velocity is negative 68.6 meter per second. Therefore, the resultant velocity will be this vector, and we are supposed to find that vector. This is what we need to find. And what is the magnitude of this vector? The magnitude is square root of Vx squared plus Vy squared. So Vf, the final velocity when it touches the ground, will be square root of Vx squared plus Vy squared. That will be square root of 80 squared plus 68.6 squared. That is 105.4 meter per second. In other words, that box will hit the ground with a speed of 105.4 meter per second. And if it is not packed well, it is likely that the box will shatter into pieces. Well, and what is the direction? We need to find this angle. You notice that the x is positive, y is negative, therefore the angle is a fourth quadrant angle. Is that right? So the angle theta is such that tan theta equal to y over x, Vy divided by Vx. And therefore theta is tan inverse of what? Negative 68.6 divided by 80, and that is negative 40.6 degrees. You see, the angle is a negative angle. It is a fourth quadrant angle. So we now found the magnitude of the velocity and its direction. A very important type of problem. Let's now do another problem. A person standing on a cliff throws a stone with a horizontal velocity of 15 meters per second, and the stone hits the ground 47 meters from the base of the cliff. How high is the cliff? We are looking for y0. We know the time of we know the horizontal distance traveled, we know the horizontal velocity. Actually, this is the same as the first problem we did. We can use the horizontal distance and the horizontal velocity to figure out the time taken to fall. Is that right? Yes. And then use that time to calculate the vertical distance traveled. Okay. Now, here is the cliff. But I did a poor job of drawing a cliff, but it's okay. And the stone is thrown, that wicked boy, I think, threw the stone from the top of the cliff with a velocity of 15 meters per second. And the stone fell at a distance x equal to 47 meters. That means x equal to Vx multiplied by time. And you know the initial vertical velocity is 0. We are looking for y0, the height of the cliff. Well, we first used the horizontal displacement x equal to Vx multiplied by time. X equal to Vx times t. We know x, we know Vx, we can find t. So t equal to x divided by Vx. That will be 47 meters divided by 15 meters per second. And that will be 3.13 seconds. Okay, if 3.13 seconds is the time taken to fall, can you tell me what is the equation we will use to calculate the vertical fall? What is y0 equal to? y0 equal to 1/2 gt squared. We used this before. So that will be 1/2 times 9.8 times 3.13 squared. And that is 48 meters. Well, what we did is started the discussion on projectiles, and we discussed horizontal projectiles. In the next part of this lesson, I will discuss projectiles at an angle. Alright? Okay, in the meantime, look through this and make sure that you understand these basic concepts. And I will see you for the next part of the lesson later on.